Altitudes and medians of triangles. Students, today we are going to see next chapter, that is altitudes and medians of triangle. Now this chapter I had explained when I took my online lesson, but some of you are not there, that's why I am doing the video again and sending on YouTube. So what is an altitude? Altitude and median of triangle. Okay. So altitude means height. So it is used to show the height of a plane above a certain point. Altitude. Height is used for people, like we say na, my height is 5 feet 3 inches, my height is 5 feet 6 inches. So height is used for people and for showing telling the height of any place, that is a building or mountain or a plane. Okay, we use the word altitude. Okay, now before studying this altitude and median, let us do some recalling, that is what we have learned last year. So last year we have learned bisectors of angles of a triangle. Now what are bisector? Bi means two and sector means section or part. So bisectors of angle means two parts of angle. So whenever any angle is drawn and we divide that angle into two equal parts, we say that we have bisected the angle. Now when in a triangle, when we bisect each angle of a triangle, okay, this bisector, all the three bisectors of a triangle meet at one point inside the triangle, and that point is known as the incenter. Okay, so what is the incenter? It is the point inside the triangle where the three angle bisectors meet. Now angle bisector, as I told you, there are three angles in a triangle, so each angle is going to be divided into equal parts. So the line which divides this angle into equal parts is known as the angle bisector. So as there are three angles, there will be three angle bisectors and they will meet inside the triangle at a point which is known as the incenter. Then next we have studied the perpendicular bisector of sides. Now like the angle bisector, these are the side bisectors, means there are three sides in a triangle and each side bisector divides each side into two equal parts. This is also bisector. So there are two equal parts of the side, but there is a condition for it. It just does not divide it into two equal parts, but it divides the side into equal parts at a point where it makes an angle of 90 degrees with the side. So that is known as the perpendicular bisector. So there is a difference between a bisector and a perpendicular bisector. So perpendicular bisector is the line which divides the side of a triangle into two equal parts and also makes an angle of 90 degree with the side, whereas just bisector, if I tell, it can go through the midpoint of the line, but there is no definite angle which is formed over there. I'll show you this. Look here in this figure. Here, see, now these two sorry, these two lines, they meet at a point, this point, and they form an angle of 90 degree, and it bisects, this red line bisects this black line, means it divides this black line into two equal parts. Now this red line can divide this black line in two equal parts in different ways. See, it can divide this way also, then also there will be two equal parts of the black line. It can divide in this way also, here also there will be two equal parts of the black line, but this will not be the perpendicular bisectors. Why? Because the angle formed here is not 90, neither here, but if we consider this line, it forms an angle of 90. So the perpendicular bisectors of sides which we have studied, okay, what do they mean? They form an angle of, that bisector forms an angle of 90 with the side. That and these perpendicular bisectors also, they meet at one point inside the triangle. Like the angle bisectors meet at a point, that is which is known as the incenter, the perpendicular bisectors of sides also meet inside the triangle, and that point is known as the circumcenter. So these two things we have studied last year. Now we are going to go to the altitudes. Now like we said, altitude is the height or which is used height. Instead of height we use the word altitude for triangle. So what is an altitude? Now see here, the perpendicular segment drawn from vertex of a triangle on the side opposite to it. So this is also perpendicular, remember, like this, but starts from where? From any vertex of the triangle. You know there are three vertices of a triangle has three vertices. So if you take any one vertex and you start a line or a segment from the vertex to the opposite side of that vertex. So each vertex has one side which is opposite to it. So like that there will be three vertices and three sides which are opposite to each of these vertices. So when we draw a segment from one vertex to the opposite side, then from the second vertex to the opposite side, third vertex to the opposite side, like that there will be three altitudes in a triangle. So like there are three angle bisectors, three perpendicular side bisectors, same way there will be three altitudes in a triangle. See here, a triangle has three altitudes. Now instead of writing triangle every time, we use this sign for triangle. Then vertex is the point where the two sides of a triangle meet. So there are three vertices. In plural it is known as vertices, singular we call it as vertex. Now let us go to the next point. See here now here. Now these are the three altitudes of a triangle from point A. This is triangle ABC. So in triangle ABC there are three vertices. This is vertex A, vertex B and vertex C. So from vertex A we draw an altitude to opposite side. Now what is the opposite side to vertex A? BC. What is the opposite side to vertex C? AB. And what is the opposite side to vertex B? AC. So we draw a segment from A to BC and it should make an angle of 90 degree. Similarly, from C we draw a segment to AB which will make an angle of 90 degree. From B we draw a segment to AC which will make an angle of 90 degree. Now how these segments are drawn? We just don't take a pencil and by the way I just want to tell you students that whenever you are doing any drawing in geometry, you always have to use pencil. But because I am doing a video and if I use a pencil the diagrams will be very light. That's why I am not using a pencil, I am using a sketch pen. But you should never use a sketch pen or a pen for that matter when you are doing any diagram of geometry. Now how do we draw this perpendicular? For that we use this set square which is there in your geometry box. Okay, I hope you know all the instruments of a geometry box. There are two set squares like this. Then there is one protractor. This is used to measure the angles. Okay, this is a set square. Then you have the scale, which you all of you know what is a scale. Then we have this divider, which is used to measure the length, like find out whether two given segments are of the equal length or not. We use the divider. As we have to do something different things, I will tell you how to use it. And this is the compass or the rounder. Why we use this? To draw a circle or draw an arc, we use this. Okay. So for drawing the perpendicular segment or any segment which has to make an angle of 90 degree, and in this case the altitude, we use a protractor. Either of the two protractors you can use. Okay. So how are you going to draw this? Now if I want to draw an altitude from point C to AB, so I will the side which I want to draw the altitude on, I will keep my set square like this. Okay, because I want to draw an altitude on this side, and I will move it until I come to this vertex C, and then I will draw this altitude. Now when I want to draw an altitude on BC, okay, I want to draw an altitude from A to BC. So if I want to draw on BC, I will keep my set square on BC and I will move. Why do I move this way? Because this angle is 90 already. I don't have to measure it again. That's why I will move until I come to this point A. Now I will draw the segment. Similarly, when I want to draw an altitude on AC, I will keep my set square over here like this, and I will move until I reach the point B and I will draw. So I hope you have understood how to draw the altitudes with the help of a set square. So like I said, each triangle will have 3 altitudes. Now these altitudes, as you can see, they meet at one point inside the triangle. So the point of concurrence. Now what is the point of concurrence? Concurrence point is a point where 3 or more than 3 lines or segments meet. Not 2, remember, there are 3 segments or more than 3 segments. So whenever 3 or more segments meet at a single point, that point is known as the point of concurrence. Now here, this point of concurrence where 3 altitudes meet is known as the orthocenter. Okay, so this point of concurrence where the altitudes meet, this point O, that is known as the orthocenter, and it is denoted by the letter O. Remember, orthocenter denoted by O. Now what is a concurrent point? See, a point where 3 or more lines meet. Now here we saw that this is one segment, this is the other segment, this is the third segment. They meet at one point. So when 3 or more segments or 3 or more lines meet at a point, it is known as the point of concurrence. And in case of altitudes, the point of concurrence is known as the orthocenter. Similarly, we have seen in the point of concurrence in case of angle bisectors is known as the incenter. The point of concurrence in case of the side bisector, perpendicular bisectors of sides, is known as the incenter, and that was what? Which center was that? Which we saw here, that was the circumcenter. So incenter, circumcenter, and now we have studied the orthocenter. Now let us see where do these orthocenters of each type of triangle lie. In case of angle bisectors and in case of the perpendicular bisector of the sides, the centers, that is the incenter and the circumcenter, they will always be inside the triangles, any type of triangle it may be. But let us see in case of this orthocenter, this is a acute angle triangle. Now what is the acute angle triangle? Where each angle of the triangle should be less than 90. Here you can see there are 3 angles, P, Q, R. All the 3 angles, they are less than 90. This is also less than 90, these 3. So when 3 angles are less than 90, it is known as the acute angle triangle. So in case of acute angle triangle, I drew this orthocenter at O. See, I drew the altitudes like I showed you in the figure. If I want to draw the altitude on PR, I have to keep my set square over here, move till I come to this vertex Q, draw the altitude. Similarly, when I want to draw the altitude on this, I move it, keep my set square here, move it, and I draw the altitude. So like that I drew all the 3 altitudes and they meet at this point O, which is the orthocenter. Now where does this orthocenter lie? It lies inside or in the interior of the triangle. So we can say that the orthocenter of acute angle triangle is inside the or interior of the triangle. Now let us see what is the scenario with the right angle triangle. Now this is a right angle triangle where one angle is 90. What is a right angle triangle? Any one angle of a triangle, if it is of 90 degrees, then that triangle is known as right angle triangle. So in this case, we again will see where does this orthocenter of this right angle triangle lie. So let us start with x, vertex x to yz. So I will keep my the set square over here. I will move until I come to x. Now this will be the altitude. If I want to draw the orthocenter, sorry, not orthocenter, the altitude on this x, OX. So I have to keep my set square over here, move it till I come to vertex Z. Then this is. So we can see in case of a right angle triangle, the 2 sides which form the right angle are the altitudes. So this is one altitude, this is another altitude. So XO is an altitude starting from X to the side OZ, and ZO is the altitude starting from Z to the side OX. Now let us see about the altitude on this point. Okay, on this side, I keep my set square over here and I move until I. Now this 3, where do they meet? They meet over here, isn't it? Like we saw in the acute angle triangle, they meet somewhere inside the triangle. But here what happens? They are not meeting inside the triangle. Where they are meeting? They are meeting on the triangle at the place where the right angle is. Okay, so in a right angle triangle, the orthocenter, where is it placed? It is on the vertex of the right angle triangle. So it is at the vertex where the right angle is formed. So in acute angle triangle, we saw that the orthocenter was uh, inside the triangle, whereas in case of right angle triangle, the orthocenter is on the triangle. So inside, in the interior, this is on. Now let us see what happens in the case of obtuse angle triangle. Now this is little bit complicated, because you can draw this and see it in your books. So now this is an obtuse angle. Now what is an obtuse angle triangle? When any one angle out of the three is more than 90, then we call that triangle as obtuse angle triangle. Understood? So any one angle, not necessary. We cannot have two obtuse angles in one triangle. Remember that. Why? Because an obtuse angle triangle, obtuse angle is more than 90, and what is the sum of the measures of all the three angles of a triangle? That is 180. So if one angle is more than 90, definitely the other two angles have to be less than 90, correct? 90 plus 90 gives us 180. So if one is more than 90, see, so suppose one is 100, that is obtuse angle. So the other two, what should be the total of the other two? It should be 80. So it cannot be obtuse. So in a triangle, when one angle is obtuse, the triangle is called as obtuse angle triangle. Now in an obtuse angle triangle, what happens? See, if I try to draw the altitude from this point M to this side Qn, I have to keep my set square over here, and I have to move until I come to this point M. But where do I come at this point M? I have to draw the segment here till here. I will extend this side. Similarly, when I want to draw the altitude from N to MQ, to the side MQ, I have to keep my set square over here, and I have to move till I come to N. So I have to draw the altitude over here. Now these two. Now let us see about this. When I want to draw an altitude from Q, now I draw this way. This I draw inside, but I want to make them meet somewhere. My altitude is now this. Forget about this part now. One of my altitude is over here, one is here, and one is here. So where do they meet? So I have to extend them. This altitude I extended, this altitude I extended till here, and this one also, till they meet at a point. And this point is the orthocenter. And where is it? It is in the exterior. It is outside the triangle, so it is in the exterior. So we have seen the three types of triangles where the orthocenter is placed. In case of acute angle, it is inside. In case of right angle, it is on the triangle, and in case of obtuse angle, it is outside the triangle. Now let us go to the next part, that is the median. We have I hope all of you are clear with what is an altitude. Altitude is the height, that is the perpendicular segment drawn from the vertex to the opposite side. Now what is a median? Mid, from the word only you can make out, it is something to do with the middle. So this is a segment drawn from the vertex. Again, it is a segment drawn from the vertex only to the opposite side. But where on the opposite side? To the midpoint of the opposite side. Here it does not require it to be a perpendicular. Remember, not necessary it will form an angle of 90 degree. So we don't need the set square to draw the median, because it is to be drawn from the vertex to the midpoint of the opposite side. So like the three altitudes, medians will also be how many? 3. And now they will also meet at some point. Now medians will always meet inside. Okay, they will not meet outside. So all the three medians will always meet inside, and their point of concurrence is known as the centroid. So we have learned 4 points of concurrence up till now. Last year we learned about incenter, circumcenter, and today we have learned about orthocenter, and now we are learning about centroid. And the centroid is denoted by the letter G. Now the three medians of triangle are always in the interior. Remember, like altitude, the median will never, the point of concurrence of medians will never be on the triangle or outside the triangle. It will always be inside the triangle. And there is one special property of the centroid, that centroid divides each median in ratio of 2:1. How that is, that also we will see now. Okay, now look here, this is a property of centroid. Okay, so from A I am drawing the median to the point, to the side BC. That is, from A I took a midpoint, I measured this side, I took a midpoint and I drew the segment. Similarly, I measured this side, I took a, see, you can see here, this angle is not 90, this angle is also not 90. So not necessarily the angles will be 90, it can be any angle. And what I found out after measuring the sides, after measuring the parts which are formed, you can see now 1, 2, 3, 4, 5, 6 parts are formed. So this BP is divided into two parts by this point of concurrence or by this centroid. And what is the measure of these two parts? One is 1.5, the other is 3. Similarly, if I see this median CQ, it is also divided by this point G into two parts, that is, one is CG, other is QG. And what is the measure of these two parts? This is 2, this is 4. Same way here also it is found out that this is 1.5, this is 3. So when many measures were taken like this, it was found out that this point G, that is the centroid, divides each median. Now if I take single median into 1:2, if this is 1, this will be double. Okay, whatever 1:2 ratio means what? If one part is some measure, the other part will be double of it, 1:2. If one part is considered as 1, the other part will be considered, it will show the measure of 2. So if one is, first part which we say is 2, the other will be 4. If one part is 3, the other will be 6. So 1:2. So from here we found out that the centroid divides each median. Now this is only for one median. Okay, so AG and GR, we consider one median at a time, and we found out that it divides it into 2:1. Now let us see what are the different points of concurrence. So angle bisector is known as the incenter, and perpendicular bisector of side is known as the circumcenter. Altitudes of triangle where they meet each other, that point of concurrence is known as the orthocenter, and where the medians of the triangle meet, that is known as the centroid. Now how to remember this? So to remember, there is one, see, this is known as a limb. So we'll learn this. Okay, all of my children are bringing in peanut butter cookies. So if you remember this sentence, you will be able to find out, because it is confusing, right? What is orthocenter, what is circumcenter, what is incenter, whether it is medians or altitude. So it's so confusing. So let us see how we are going to remember. So you just have to remember this sentence. All of my children are bringing in peanut butter cookies. What is all? Altitudes. Off for orthocenter. My medians. Meet at children is centroid. Angle, R is for angle, bringing is for bisectors, in is for incenter. Peanut is for perpendicular, B is for bisector, and C is for circumcenter. So in this way you will be able to remember the different points of concurrence. So altitudes meet at orthocenter, medians meet at centroid, angle bisectors meet at incenter, and perpendicular bisectors meet at circumcenter. Isn't it easy to remember? So let us you remember this, and I will tell you what exercises you have to solve.